Okay, it is 11 o'clock on Wednesday, September 18th, 2019 at Collin College in beautiful downtown Frisco. This is the scheduled meeting of ITSE 2309 at Collin College. And let's see, today we are, let me minimize this thing. Okay, today we are in Module 6. I have not graded Module 5 yet. Module 5 is due today. So if you get it in on or about the due date, I guarantee that you will have time to correct any issues that you have that, if you go right up onto the cutoff day, I don't know whether you'll have time or not. So anyway, Module 5 is due. That doesn't mean that that you get a 0 if it's not in today, but let's see, so today we're going to cover Module 6. Now, Module 6 is talking about joining tables. What do we mean when we say join a table? And I mean, basically, you follow the primary key, follow the primary key to the foreign key, or vice versa, whichever way you're thinking. And it is a way to see the relationships, see each parent with its respective children. So if we were talking about pets and owners, I would see the owners and all of the pets that that owner had. If I were talking about doctors' patients, I would see the doctors and all of the patients that that doctor had. So I would see records that participated in that relationship. Now, there's a very good video here. I recommend it, overview of joining tables, and you might want to look at finish the rest of my recording first, and then look at Dr. King's, Jamie King. He's kind of funny, and he speaks very quickly. As some students have trouble understanding him if your English is second language, but he's worth. You can listen to him over and over, and he's free. And joining tables. Joining tables says basically I have a parent and a child. Now I've named these tables parent and child. I should have shown dropping the tables if object ID child is not null, drop the child. So I should have dropped the child and then dropped the parent. Nonetheless, I got sloppy here and I just created them. And the only thing I have in there is one letter, one character. Oh, grief. I'm going to throw this phone. That one letter. So the parent is just a parent ID. That's it. It's like A, B, C. A child has a child ID and a foreign key parent ID. So the child has a primary key and a foreign key. Insert into parents the values A, B, and C. 3 of them. Insert into child the values X, Y, and Z. Child X belongs to parent A. Child Y belongs to parent A. Child Z belongs to parent B. And parent C doesn't have any children. Okay, that's fine. None says they do. It's just that the child, if I have a child, I could not insert a child Q referencing parent X or something like that, because I don't have a parent named X. Okay, all I have is A, B, and C. And now I could have put a not null constraint. This particular set of tables, these 2 tables, will accept orphans, and an orphan is simply a parent record that has a null foreign key for the child. Okay, there's nothing wrong with that from a database perspective. Now, if you don't accept orphans into your business model, that's your business. That's the way you run your database. If you have if you're a doctor's office and you have doctors, and then the child is the patients, and you might not you might not want to allow a patient with no doctor in there because you're a doctor's office. Why would I have a patient that doesn't have a doctor? They got to go with one of them. So I don't know. That's up to you. There's nothing in a database that makes that wrong. What is wrong is if I have a child with an invalid parent. Now I've got a problem. Okay. So let's put this in here. Basically, a join is, and I'm doing this the old way. I'm going to go back over here and I'm going to select. Now, this is an old method of this. There's a newer syntax, but select PID as primary key, CID, C child.foreign as foreign key, and CID. Okay, now here, from parent as P. I usually will rename the tables. I didn't have to do that. I could have just said from parent, comma, child. I renamed parent as P and child as C for one reason. I just love typing. No, I don't, and probably neither do you. So if I rename them now, any other time, because remember I told you that the from line was what got executed first. If I rename something on the select line, I can't use it anywhere else in the query. But if I rename something on the from line, that's the first thing that happens. That name is now existing throughout the query. So if I name parents as P, from now on, that table is named P, and I don't have to type P-A-R-E-N-T-S. From now on, the child table is named C, and I don't have to type C-H-I-L-D. That's the only thing it gets me, yes.
So is the parent table still existing?
The parent table hasn't changed any. Its name, it just picked up an alias. It's known as P. Okay. That's all it's changed. It still has the same primary key, still has all the same data. Nothing has changed, except instead of typing parent, I can just type P. If you want to leave it parent, that's fine. In that case, you would have to say parent here, parent here. Okay. Now, when I say from, when I put two tables in there like that, even whether I rename them or not, and I put a comma between them, what I'm going to do is I'm going to join those two tables. Joining the tables means I form every possible row that I can make out of those data. Everything from the P table joined with everything from the C table. Let's see an example of that over here in the web page. Here it is. So what did I have? I had I had AX, AY, AZ, BX, BY, BZ, and CX, CY, CZ. So every possible way I could put that table together, those two tables, the data together. So if I had 5 rows in one table and 4 rows in the other, how many rows would I have in that output table? Well, when I had 3 and 3, I had 9. How many would I have if I had 4 and 5, 4 in one table and 5 in the other? 20. Thank you. Multiply. And that is called a cross product join or a cross join. In other words, just make every possible row you can make. Now, which rows am I interested in? Which rows are those that follow that primary key? Well, I'm only interested in rows where the primary key of the parent is equal to the foreign key of the child. Notice the foreign key and the primary key are, match on line 1. That's one I want. That's a relationship. Notice that they also match on row 2 for the child name X and the child name Y. Row 3, they don't match. Row 4, they don't match. Row 5, they don't match. Look, on row 6, they match again. B is matched with child Z, zeta. Row C, primary key C, does not have any children. None of them match. Okay. Result has 9 rows and every possible permutation. Okay. Permutation is when order matters. This is also called a cross join or a cross product join, and it's discussed on page 148 and 149 of the textbook. There's more modern syntax to this. Okay. Questions? Okay, I'm going to go on. Which rows really contain the information we want? Well, these guys. Now let's look at this one. So this one I have added the primary key match into. So the line 37, this one is a cross join, which isn't really very useful to us most of the time. It produces one heck of a lot of data, but it's not real helpful because the database person is always trying to trim the data down to just to the parts that I want. So let's look at what we call the inner join. So this is an inner join. And I say old syntax as if that's bad. It isn't. This is also called the implicit syntax. Old, also called okay, and sometimes I might ask you to do a join using the implicit syntax. Now look what I've added here. I've done exactly the same thing. The select is exactly the same. I've renamed them exactly the same as I did above. I just copied and pasted, and I added that into the where clause. The where says where the primary, the PID of the parent table is equal to the foreign key in the child table. Now, notice that these guys have the same names. The PID is in the parent table, and there is also a PID in the child table. I think this is desirable. Some people do not think it is desirable, but oh well. Some people have other conventions on naming. If you named them differently, there would be some things that would change. Notice that I must have the table name in that where clause. I must say P dot PID is equal to C dot PID. Do I need to run that up on the board more? Okay. Because if I didn't say that, then I would get a ambiguity, meaning that it's in both tables. So I have to specify the table name with a dot. Anything that is not in both tables, I can just give the name. For example, on this one, when I say select P dot PID, and I named that one as primary key, I had to say P dot PID. Why? Because I have another PID in the select line, in the join. So I had this one, I had to specify the table name, and the table name is P, because we named it that. C is the child. But notice when I was talking about the CID over here, I didn't have to say C dot CID. What if I had? If I had, it would have been fine. Wouldn't be a thing wrong with it. So if you always specify the table name, then that's fine. Most programmers don't, because we love typing. Other questions? Now this is the table join. Okay. Let's see the output of this table join, and we should see some. Execute. Notice that here I have just the primary key and the foreign key. I'm demonstrating that the primary key always matches the foreign key, AA, BB, and that the child comes along for the ride. Probably I would suppress the foreign key if I were doing this as a query for something. I really don't need that child key in the output. It didn't do me any good because they're always going to be the same. It's always going to be A, B, B, C, C, D, D, E, E, F, F, whatever, however many parents I have in there. Now, notice something else about that output. What do you see that's kind of jumping up and down at you in that output? On the board, on the screen. What do you notice about it? There's something that's missing. Amanda, can you see it? I'm not getting any. The what? I don't have any orphans in this. There aren't any orphans. I would know that I had an orphan if I looked at the child table and I found some nulls in there. That would be an orphan. I would not see orphans in the output though. If I had an orphan, I could put an orphan in there pretty easily. I might do that in a second. We might put a child O for orphan in there. There's something missing. What's missing? Well, look at it. There's something missing. Do I have all the children? Yes, I have all the children. What about the parents? What parents do I have? Look at my parents. I don't have C. Why don't I have C? Because C doesn't have any children. All right, this is one of the properties of this kind of a join. Now, write this down in your the notebook or whatever. Whenever I have this kind of a join, this is called an inner join. An inner join. A property of the inner join is it only shows rows that participate in the relationship from either table. If I have anything that does not participate in the relationship, and let me go ahead and add one more in there. How about let's insert an orphan into the child table. XYZ, here's an orphan. This, that's O for orphan. Okay. And we'll insert a null. There's nothing there. Now there's nothing stopping me from inserting the null. By the way, I'm using Scratch, but we're mostly going to be using APDB now. Okay, so I have inserted him. And when I do the cross join, if I were to look at that, notice I see my nulls in the cross join. I see the nulls. Now I have 12 rows because I got 3 in one and 4 in the other. The nulls show up there, but the nulls are never going to be equal. When I get down to this one and I look at the inner join, I'm only going to see the parent A, B, and C. I do not see the orphans. I do not see the childless parents. This is an important point of the inner join. The inner join only shows you records that participate fully in the relationship. You won't see if you had children with an invalid parent. You better not have, but there's a few times in there where in my data, if you go looking through my my AP_DB data, you're going to find that I have put in there deliberately children with invalid parents. They're there. There's one or two sprinkled around through there just to give you something to find in your joins. Okay, but you won't find them in an inner join. Okay, questions. I hope I started the recorder. Yeah. All right. Records that do not participate in the relation, childless parents and orphans, do not appear in the output. An inner join will return neither orphans nor childless parents. Amen. I have said it. I have spoken on that matter. Guess what will be a test question too? Inner join. Only see records that are both sides, that have a foreign key and a primary key, and they're equal. If you think about it, and if you look at this, this guy right here, where the parent primary key is equal to the child foreign key, if I don't have a child foreign key, it can't ever be equal, so I won't see that parent. If the child is null, nothing can ever be equal. Parent primary key can't be null. And even if it were, they wouldn't be equal, because null is not equal to null. So I won't see childless parents. I won't see orphans. I will not see children with invalid parents either if I'm looking for them. There will come a time in your life and database where somebody will set up a table. It invariably happens in an early class where they just make a table and start throwing data at it. That's why I hate those books that do that. Like anybody take that ITSW 1307, I think it is. It's a Access, and it's a Shelley Cashman textbook. And what they do, they just, okay, create this table. Now you start throwing data into it, and they have foreign keys and primary keys, and somebody will invariably fat finger the name of a foreign key, and not the name, the data. So they'll have, it'll be a student ID or something, and somebody will invariably make a mistake on it. Now they have invalid child. So this child's student ID references the roster's student ID. So this is a child, and I got a parent, and the child has an invalid parent. But that's okay, because we haven't created that relationship yet. Then you go back in and you try to add the foreign key constraint. And yes, we can add constraints after the fact. But what's going to happen if one of them's invalid? Eric, we come to a screeching halt. And it says, sorry, you can't do that. Oh, well, what's wrong here? And the student's hand goes up and, Dr. Smith, my program's not working. And I say, well, that's because you have a mistake in it. And we should never have allowed that to happen. We should have put the constraint on first, and then it would have stopped you from putting those bad data in there. Now you have to go in and try to find them, and we're going to learn how to do that in this chapter. But we can't do it with a inner join. Okay, let's see. What did I have for you to do? I had something here. Try it before you move on. Before you leave this, see the solution and see the write a query. Okay, here is your task, and I want you to do it. Amanda, you can participate in this also. Write a query demonstrating an inner join. Okay, that was carry on. That returns all vendor name, invoice number pairs. What is the vendor name? Vendor name is spelled just like that. It comes from what table? Vendors, yes. I believe it's the primary key of the vendors table. Let me see if it is. I'm guessing it is. I'm not sure if it's not. Okay, so you're going to use APDB for this one. Tables. By the way, get in the habit of looking at this Object Explorer. I want to know about the vendors table. I should not have gotten the owners in there. Oops, I can't. I'm going to have to get pets first. Okay, pets. Somebody. Okay, so I'm interested in vendors. If I look at the columns of vendors, it will show me, okay, vendor name and vendor ID. This is a poor example to say I want to see vendor name and vendor name and invoice number pairs because the vendor name is not a primary key. All right, so that's not a database person would not like that. A database person would not like that at all. But vendor name, I'll tell you, vendor name is unique, but we don't know it's unique. Vendor name just happens to be unique. So can you do that? Can you write that join using this one as a model? Can you write the join? Select. You can just select two fields. You don't have to have, for example, I have the child foreign key in my output, but you don't have to have that one. Right. This is more common, having it like this, just the primary key and so your output would look something like this. Just the vendor ID. You don't have to print the foreign key. Okay. So how are you going to start? Mm-hmm.
We're supposed to be using @_DB, right?
Good question. That was my first. How are you going to start? And you're going to start with by choosing the database. Use AP_DB. Yes, sir. That's indeed correct.
The only thing is that, well, we also use this database on the assignment for today.
Yes. Mm-hmm.
But I didn't have the table, didn't have any data on it. I don't know if I
Okay.
skipped that part. So I went in the textbook and I realized that you have to download the files.
No. Use my file because I've changed some things in the file. I've changed some things. So we'll when we get to lab today, we will. You can still use the other one though for this, but we'll get that straightened out in lab today. Okay, so first is going to start with use AP_DB. And then after that comes what? Select. Open a new query. New query. Use AP_DB. Then you have a select. Select what? No, you see, you already got the data. You selected the database when you said use. So now you're going to be selecting something from a table. What's the name of the field we want? One of them. By the way, there's no order to a inner join. You can do it in any order. Select. Come on, what's the name of the table? No, the name of the field, excuse me. Okay, let's go back and read it again. What does it say? What? Demonstrate an inner join that returns all. You're stopping halfway through the word. Vendor name. So what's the name of the field? Vendor name. Select vendor name. You could say vendor dot to vendor name would be okay.
Next time.
Who's that? Who's speaking? Edward, is that you?
Okay. Oh, yeah. I'll click.
Okay. If you have a question, you can unmute. I'm going to go ahead and mute. If you have a question, just go ahead and unmute your microphone, and I will. And I'll be able to hear you. Or I just turned it off for a second. Wasn't sure you had a question. Okay, I'm going to go start. New query. Use APDB. Select. Okay, now I can say vendor. The question is, will I have vendor name in there twice? Okay, it is okay to, I can come back and I can add, I can say vendor dot vendor name later if I get an error. I'm just going to say vendor name for now. Vendor what? Excuse me. Invoice ID. Now, what is it? What tables do these come from? It's always going to be, inner join says join two tables. What are the two tables? Vendors and invoices. From vendors invoices. What is it that joins? What is the foreign key, parent key that joins invoices and vendors? What is the primary key of vendors? I see it right there. It's got a key beside it. Do you see the key? What is the primary key? Vendor ID. What is the foreign key that references vendor ID? It is also named vendor ID, as I usually will have it. So where and look, I have red lines. Why do I have red lines? Exactly, yes. Okay. So it says ambiguous. Do you know this word ambiguous? What does that mean? Give me ambiguity or give me something else. Okay. So I need to say vendors. Vendors dot vendor ID. And this one I need to say invoices dot vendor ID. Now my red lines are going away. I hope they go away. Yes, they went away. If they don't go away and you know they're right, just trust yourself. If it runs and does, sometimes you'll have a red squiggle under stuff and there won't be anything wrong with it. It'll run just fine, but it's sitting there with a red line under it. In that case, just you go worry about it, okay? I mean, there's a way to turn it off, but if it's running, don't worry about it. Okay, let's find out if it runs. I'm going to say execute, and I get okay, that one ran. And what did I get? I got 113 rows. And notice, let's see, vendor name IBM is associated with invoice ID 19. Vendor name IBM is also associated with 52. Blue Cross has 3 of them. Pacific Bell's got a whole bunch. Okay. Now, questions on what we did there. Sometimes if I had, what if I wanted to print out, what if I wanted to show the vendor ID in the output? What if I had vendor ID in the output? Why am I getting a red squiggle under it?
Doesn't it know which of the vendor IDs to show?
Bingo. Now what's your name, please?
Daniel.
Daniel. What did Daniel just say? It was very important. Yeah, it doesn't show the vendor ID. Why not? It's got a red mark under it. You see the red mark? Why? There's a reason. Oh, it is. It's a vendor ID is in both tables. Which one do you want? Now, what? Yeah, you have to tell me which one you want. You have to tell the computer which one do you want, because it's not going to make a decision for you. Now, if you look at this, aren't they both going to be exactly the same? Does it matter which one you want? It doesn't, not a bit. Okay, I usually choose the primary key when I'm, if I have to choose either the vendors or the invoices. You're going to get exactly the same output, either one you choose, but you just have to choose one because the computer is not going to do it for you. You have two names that match. They're two different tables. It doesn't know that they're the same. Okay, so I have to say, I will usually say vendors, not vendor ID, and now my red line should go away, and it did. And now I'm going to get the output. I'm going to get the vendor ID with it. There's the vendor ID. Okay. Now, what I usually do, I usually will rename vendors as V. I will usually rename invoices as something. Notice I've picked up some lines there. Why? Because I've renamed them. So now vendors, it can't see vendors anymore. It only sees V. So I have to change this to V, and I change this one to I. And then this one up here to either V or I, whichever it pleases me to make it. And then I have done the inner join with fewer keystrokes. I didn't have to type as much. It does absolutely nothing else except renames the tables to keep me from typing. Most of the time, when if I'm doing a join and in Access or something like that, and then I go look at the SQL that it generates, it will just type, vendors and invoices. It'll never rename them like I do. That's for human beings. Questions? Online people, questions? You can drop the as. You will see people do it that way. You will see this written like this: from vendors space V, invoices space I. You will see it written that way. Now your uncle might write it that way. If he does, that's fine. I'm not going to argue that he's wrong. I want you to use the AS, vendors as. You can also rename the, on the select line, it's as an alias. So vendor ID as I can rename it as X if I want to. I don't know why I'd want to. I don't do that very often in an SQL statement because I almost never care what the name is, as long as it's something. As long as I have some name on it, I'm happy with it. So I don't typically change it just because I don't like that. I don't like that name. I don't care. But if I rename it, I want you to use the as. Now I'll see it named X. That's fine. You can name it X. You can also drop the as in there, but don't. In this class, I'm just mentioning it because it can be done. I'll talk about the things that you can do, but I don't want you to do it that way. So I want you to use the as when you rename stuff, even though I know lots of programmers don't. And you might not either when you get out of this class. So I don't sometimes. If you take the advanced class, then you do as you please. I don't enforce that in the advanced. Questions? Okay. So this is both of these. This is the old syntax. This was the way we used to do it when I was a kid and had to walk to school 2 miles through the snow every day carrying a hot potato and eating a cracker. Okay, that's old syntax. This is pre-1990 syntax. Now, about 1990, they made some changes to the syntax. They still kept the old stuff because the old stuff still works. There is nothing wrong with the old syntax, but you need to learn the new syntax because that's the way that they're teaching it now. So I start with the old syntax because, in my opinion, I think the old syntax is more intuitive because I just say vendors invoices. When I just say vendors, comma, invoices, I get it put together every possible way. Now, let's do this with the new syntax. It has changed. Everything is still there. It does the same thing. Nothing is different, but I'm going to rewrite this in the new syntax. Here's the new syntax. Okay. Select. Okay, I'm going to use the V. Okay, so I'm going to rename them as V. All that still works, okay? So select the same stuff from vendors, but instead of having a comma between them, okay, instead of the comma, we drop the comma and it would go INNE, inner join. Inner join. Do not write join. Okay, do not say just plain join without writing inner. Do not say vendors as V, join invoices as I, or I will take off points on your paper. Will it work? Well, if it wouldn't work, I don't have to tell you not to. Yes, it works. You can just say join and you can reduce some typing a little bit, but I want you to say inner join to differentiate that from an outer join, which we're going to do next. Okay.
So we could like take the word from the word.
If you do, I'll get even. Yes, to answer your question, can you take out, can you do it without this? If you just wrote this, would it work? Yes. Yes, and that would be an inner join. Yes. Don't do it that way unless you just want to try it that way. You can try it that way. But
Type inner join, but now you raise the word clause.
I'm sorry, I did not understand that.
So you type inner join, but now erase the word clause.
No, no. Oh, I haven't gotten to the where clause yet. Yeah, where clause changes. And instead, notice that the where clause is now giving us a red line. So it's changed a little bit. Instead of where, it has changed to on. Inner join on instead of where. Now, if you think about it, the and I'm gonna add some stuff to this. So this is the new syntax. Let's say I only want to see records where the vendor's address is in California, that's CA. Okay, so up here, it's pretty easy. Where, I usually put this first. Now what do I have? And what? Remember, I only want California. Vendor state. Do I have to say vendors dot vendor state? Why not? I see you shaking your heads no. Why not? Okay, so what's your name, please? Huh? Dolph? Dong? Dong. 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 Okay, it's only in the vendors table. Is that what you were going to say, Daniel? Is that what you were going to say, Hamna? Okay. And you said it too. Okay. Lucy. Okay. I'll get. I start getting names right about the end of the semester. I get everybody's name. All right. So vendor state. I don't have to put the. I don't have to put vendor state, but if you did, more power to you. You like to type. That's fine. And so if I do this, I'm not going to output the vendor state. I don't see the vendor state, but notice now I only have 39 rows. A minute ago I had 113. If I add it the same way. Okay. Works the same way down there. Okay, now in the, here's where it gets a little bit different. When we have the on clause, now I have a where. Okay, now notice how the new syntax is, notice how new syntax looks a little bit different from the old syntax, because in the old syntax, the join field, notice this one right there, where the primary key is equal to the foreign key, that goes in the where clause of the old syntax. But in the new syntax, we picked up a new line up there. It's called on, and the on is where the join field goes.
Wait, what did you say about the join field?
Well, what do I mean? What is a join field, Hamna? Yeah, it's the foreign key primary key that's driving everything. So the join field is where the invoice ID in the invoices table, excuse me, the vendor ID in the invoices table equals the vendor ID in the vendors table. So when those guys are equal, we say that that record is in the join because they have the foreign key equals the primary key. So a join fields, the join field, sometimes it's just you just say field, is the foreign key primary key pair. It will always in this class be a foreign key primary key. It is not always true that it is always so, but we'll say it is. And where it isn't, oh, well, it isn't. There's nothing that says it has to be the primary key, but it doesn't make any sense to join my shoe size with my employee ID. So I have one table of wardrobe and one table of employment, and why would I join my shoe size and my employee ID? And people will do that. They will join their vehicle registration number with their, I don't know, with the name of their favorite dairy product. And what relationship is there? They don't get anything back, or sometimes they will. They might just accidentally be equal. So if I were joining my shoe size with I don't know, the room numbers of the class, and my shoe size were 11, there might be a room number 11, and that would join. Okay, what does it mean? Nothing. So if it isn't a foreign key primary key pair, it probably means nothing. And if it means nothing, it's probably not a primary key foreign key pair, because if that's an important relationship, it's already set up as a primary key foreign key. Okay, I can have as many foreign keys as I want. Now I can go through this, I can keep following it on down. But this one, let's see, 39 rows. So if I were to execute this one in the new syntax, again, I get 39 rows. In the exercises, I ask you to do one with the new syntax and one with the old syntax, or a couple of them. Okay. Now, one more I want to do while I'm here. I want to throw in something from yet another table. So what is it that, so get used to looking at this Object Explorer. I have invoices. Let's see, invoices. Terms. Okay, so terms ID. So I can throw in another table. And so I want to add something to it. Which one do I want? Okay. Invoice ID. So I'm going to go to the invoice line items. And I want to add the invoice line item description to it. I think I won't do that right now, as we are at 11:54. It's time for us to take a break. So I always try to give you a break on time. And when we come back, I'll talk about that, because I'll be here for a while. But I can put together as many of these as I want to. There's nothing that's, I don't have to stop with just 2 tables. I can have 3 tables or 4 tables or 5 tables in the join. The only thing is that all of the tables have to be related. So I start with I don't know where I start. Do I start with the primary key, or do I start with the foreign key? It really doesn't matter, as long as there's a thread through it. So I start with, let's say I start with the primary key, follow it to the foreign key. That foreign key might, that table with the foreign key might have a primary key. That primary key has its own children. So I might have a overall outside table, a parent table. Under that, I have the children table. Under that, I can have grandchildren and then great-grandchildren. So I can follow it for as long as I want by this same syntax. If I'm doing it in the old syntax, and I actually like the old syntax a little bit better, I just start off and I put all the tables in there that I need. So I might need, from parent table, child table, grandchild table, and all that. And then I have to start linking them. So every time I have 2 tables, I've got something linking it on, or excuse me, the where, and I have the primary key equals the foreign key. And the primary key of the next table equals the foreign key of the next table, and the primary key equals foreign key, and so on down. It's kind of like putting together railroad cars, I guess. I've got two tables. They're linked on a joined field. So they just go together like that. Let me see what I've got in the terms of this guy. The self join, okay, I'm going to talk about that. Multi-table joins does that. Let's look at the inner join. I ask you to do do that one with that we just did. You're not supposed to look back, just do it. Explicit join. New syntax is also called explicit join. Okay, I'll give you this file. So this says use the explicit join. And then I do another one and I say use the old syntax, implicit join. Explicit. Okay, each one of these is worth 20 points. There's two pieces to this join. I have not finished it yet. Now we are coming up on to test one. It falls after we do this section. So I think I'm probably going to end there for today and move to lab. And we'll get anything fixed. You should stay and work on this in lab instead of hitting the door like a fire drill. So I'll be here working on it with you and getting you started. And Daniel will fix that matter with your database. Okay, I'm going to take a short break, run to the bathroom. Questions? I'm going to pause the recording. I guess I better turn on the recording for that. Amanda just asked me about the test and what is the format of the test, and I guess I need to say that. So I'll cover that right now before we take a break. Test is online. We do not take up class time for the test, and I typically will make it span a weekend and a weekday on either side. It will have a time limit of usually plenty of time. What I think is plenty of time, it never is enough. It will have a time limit and say I expect you to be done in 3 hours, but it's not rigidly enforced, meaning that I don't want you to start and then finish it up 2 days later. So I want you to sit down and do it. So it'll say something like you have 2.5, 3 hours, whatever it is I have on it. But like I say, I don't rigidly enforce that. You do better by just, if you have to go over a couple of minutes, go on over. Don't go over the time on the test. When the test is over, it's really over, meaning that if I put the test out and I say the due date on the test is Monday at 5 o'clock in the afternoon, that means Monday at 5 o'clock in the afternoon, it turns into a pumpkin. So don't go past that. But if you start the test and you go past the 3-hour time limit a little bit, that's not a big deal. And let's see, it will be essentially a lot like what we've done. It will have create a table with a foreign key, with a primary key, foreign key, add some data to the table, manipulate some of the rows, just like we did in the exercises. It will have select from where queries, and it will cover table joins. Okay. Now we have covered one kind of the table join. I'm not quite finished with it. I'm going to come back from break and carry on a little while longer because I don't. Wednesdays are typically all lecture, but they won't be all lecture. Okay, Amanda, did I answer your question?
Yes, I think so.
Any others? Okay, I'm going to take my break. Pausing the recording. Resuming recording. Now I'm getting some questions on the where is the AP database. Now we have two databases. We have one that is the Scratch _DB, and that's the one that we're just, anytime we want to create something just for the fun of it, an owners, a pets, a doctors, whatever, we'll create them in Scratch because we don't want to clutter up our AP. Under the AP DB, okay, let me see. You find that file to create the AP database under the module 2. So go to your modules, go to module 2, page 5. Module 2, page 5. Create the accounts payable database. And so we'll go here. Now, before you do this, this says you're going to create the new database. So check and see, do you have the database created? Daniel, do you have the database created? Under databases, do you see AP_DB? If so, don't create it again, right? It exists, okay? If you don't have it, you're going to right-click databases and you're going to say new database and you're going to create AP_DB. Okay. Now, when you're ready to do that, okay, you need to have this file. So get this file. So here's the file. Download the file. Create AP_DB. I already have mine downloaded. I believe it's on my desktop. Okay, I've already got mine downloaded. Put yours someplace. Put it on your flash drive. Put it somewhere. You guys with me over there? Put your AP someplace. Mine's on my desktop, wherever you want it to be. And then I'm going to open it. Easiest way is to open the file. Create AP. It looks like this. This is SQL. Take a look at it. What does it start with? Use AP_DB. Put it in that database. What does it do? It drops all the files, drops all of the tables. Then it starts off creating the tables, creates the children table, creates the table, creates the table, creates the table vendors. Right. Creates the table invoices. And once it gets all the tables created, then it starts putting data in them. When you get this, and so you can take a look at it. By the time you get done with this class, you will know that how to read this pretty well. Just go up here and say execute. About 3 or 4 seconds later, it is executed, and now you have all of the tables. You should not get any errors. Let me double check and see if there's anything else I need to cover for today. Sometimes you will join a table with itself. I don't believe I have any of these, but a table may be joined with itself. For example, this is usually found when you have a self-referencing table. It is possible to have a foreign key in a table that references the primary key of that table. This is most commonly found in a table of employees. So an employee has a employee ID, has a name, has a department, phone number, all the usual stuff that you're expecting the employee to have, and an employee has a supervisor. So an employee has a supervisor. What is a supervisor? A supervisor is also an employee. Therefore, would not the supervisor be in the employees table? Would not the supervisor have an employee number? Yes, no problem. So the foreign key of my record employee has a foreign key. What does that foreign key reference? It references the table itself, the employees table. So I have the parent and the child are in the same table. Well, that's perfectly legal. There's nothing wrong with that. Let me see. Let me create one quickly. Okay. Create table. Employees. Let's see, there is a primary key. E-name. Now, I'm going to get a little lazy here because I don't want to put a whole lot of effort into this one. E-name, I'm just going to say E-name is a varchar. Oh, I don't know, 16, I guess. Now, this will work. This is considered poor practice for a database, but sometimes if you just want to demonstrate something, it is acceptable. I don't want you to do it that way. This is called an inline constraint. In other words, the constraint is part of the definition. So instead of giving the constraint a name, I just say primary key. And what it is, it's an unnamed constraint. The system gives it its own name, whatever it is, like B2257193 underscore XC. It just gives it a gibberish name. And now if I want to drop that constraint or something, I have to go and figure out what its name is. But I can do it that way. Okay. So I have, I'm sorry. Oh, let me get finished with this. Also under e-name, e-super. Let's see, what is my problem here? Okay, I have to put the employees. There. Okay, I've created the table employees. Now, employees has an e-name that is the primary key. And it has another field that references that. So I can have a insert into employees. E-name, E-super. Values. And what's the first one I'm going to insert? This is Mr. Big. He's the boss. Mr. Big. Now, he's the boss, and who is the supervisor of the boss? The boss does not have a supervisor. And that's one of the problems here. How do I put a supervisor in for Mr. Big? If I put a supervisor in for Mr. Big, there isn't anybody in the table. Okay, so I have to first put that in as null. Okay. Now I can insert other so Joe is supervised by Mr. Big. Bob is also supervised by Mr. Big. Now I can put in Tom is supervised by whom? Tom can be supervised by Joe. And so on. Okay. Now, if I want to see pairs of it, when after I execute this, and I can put in as many people as I want, the only issue is where, oh, okay, well, it would be nice if I created it first. So now I should be able to insert. And I've got 4 rows in it. And now if I want to see the employee pairs, I do select. Sometimes I'll just select E-name, E-super. From as E1. Now here's the rub on this kind of a join. I must rename the tables, at least one of them, because I'm going to have employees joined with employees. So typically I will name one of them E1 and one of them E2 on E1 dot. E-name equals E2 . Okay, now I'm going to have to say which ones I want here. So I'm going to have to say, I'm going to take these pairs from both from E1. Okay, now this should show me the employee and supervisor pairs. So as I execute this, I find out that Mr. Big, no, that'd be E2, wouldn't it? What's going on here? Employees E1, enter join employees E2. So I want to see Tom and Joe. E1.name, E2 employees as E1, inner join employees as E2. That should be right, but it's not. I'm going to have to think about that. So let me get back to you on this one, and I'll go back over this stuff again, and I'll get a good example worked up for you, where we join a table with itself, because a primary key and a foreign key can both be in the same table, and that's actually that's very common to do. I've got something wrong with this somewhere, but I was just trying to do it quickly. I'll go in and put it in there and give it to you next time. Okay, the next topic that we're going to take up, and I'm just going to kind of point to it right now. I don't think I'm going to finish it today, because I usually allow 2 class periods for this one, for this this module. We have an inner join. Now, what is the property of an inner join that we looked at? What did I say the important property was to remember?
One show pairs that don't have a
Okay.
parent.
Only shows the pairs of records that participate in the relationship. Okay, childless parents, no. Orphans, no. Now, there is another kind of a join that is called an outer join. An outer join, O-U-T-E-R, outer join. An outer join is different from an inner join in that an outer join will show, has a left and a right table. And so one of them comes first, that's the left table. One of them comes second, that's the right table. So an outer join is a left outer join or a right outer join. So if you say table A, left outer join table B, the table on the left is A. You will see all of the records from table A and the records in table B that participate in the relationship. I'm going to show you that this is how you find unmatched records. So we're going to talk about finding. Now I want to see the childless parents. And we're going to say that I can see them. Now for that, I'm going to need the outer join. So I'm going to leave that until next time. You can read about that. The assignment from this module contained, I've broken it into 2 pieces, so I can go ahead and make the assignment for the inner join and leave the outer join. So I typically do this on two different days. So today we have done the inner join. I'll finish up with this self join with an example next time. And I'll make the assignment here, make the assignment due. And I am also, I'm going to give you the practice test. I'm gonna turn on the practice test for test 1. So I give you some points for doing it. Find that the people who do it actually do quite well on the test, because it's going to look just like the test. Amanda, did you get that? That's should answer some of your question about what's on the test. Look at the practice test.
Yes, I got it.
Okay, I'm going to go ahead and make that available. I'm going to assign it. I usually give like 5 points for it, and I don't agonize over grading it. If you do it, you get your 5 points. But the good thing about it is if you do it, and I will also give you the key to it so you can grade it yourself. I'm not going to give you the key right now. So I'm going to go ahead, I'm going to give you the practice test. I think the test will probably become available. Let's see, I need one more Wednesday to do outer join. I think we'll be ready for the test to begin in week after next. Will come the test. Okay. All right, I'm going to end the recording there.